Woohoo! All right. So now the problems are all mixed up. So like I told you guys yesterday, when you read the problem, you gotta ask yourself, is this a permutation or a combination? Should I compute it directly, or should I do the complement and subtract it from the total? Oh, so that's not bad. That's not that many questions. Well, that's because most of us didn't even do it, Mr. Butler. Oh, no eye contact on that one. How many 5-letter words of different letters, that means no repeating, can you use using the letters of the I like logarithm, because they're all different letters. If each word must contain at least 2 vowels. Now, how many vowels does logarithm have?
3.
So what are the 2 cases? Either 2 vowels or 3 vowels. Or should I do the complement? 1 vowel or no vowels subtracted from the total? No, that's like more computations. Why subtracting hard? Because you got to borrow. Okay, so here we go. How many? I forget. How many letter? 5-letter words. 1, 2, 3, 4, 5. Okay, let's do 2. Let's say the 2 vowels are here and here. How many choices do you have?
3.
There are 3 vowels, so 3 and then 2, and then the consonants.
6.
6, 5, 4. But is that the only case? Vowels in positions 1 and 2? No. So how many cases? What?
5 factorial over 2 factorial. Right?
Almost. 5, choose 2. Or here, or like this. Think about it like this. Vowel, vowel, consonant, consonant, consonant. How many different orders can you put 2 V's and 3 C's in? That's like Mississippi again, right?
Oh.
So 5 factorial over 2 factorial, 3 factorial. Which is the same thing as 5 choose 2, or 5 choose 3, which is like this. Out of these 5 positions, how many ways can I select 2 of them to be the vowels? Or out of these 5 positions, how many ways can I select 3 of them to be the consonants? Or you can think of it as how many 5-letter words you can make. But whatever, you're going to have to multiply by 10. Or how about just count it by hand? Like here. The vowels could have been here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can always count it by hand if you wanted, but you got to get 10 over there. And then what about 3 vowels? 1, 2, 3, 4, 5. Let's say the vowels are here, here, and here. How many choices do I have? 3, 2, 1, and then consonants. 6 and then 5, and then what do I need to multiply by? 5 choose 3, or 5 choose 2, or this thing there. Whatever it is, it's 10, right? And then if you write down that formula, make sure you have the plus sign there, yeah? If you write down that formula, you get 3 out of 4 points right there. Okay, number 10. Number 10. A group of 10 people order from a restaurant menu that lists 3 main courses. This problem is on the test, I'll tell you right now. Fish, chicken, and steak, except could have more choices. How many combinations of main course orders are possible with this group? So like here, you got fish, chicken, and steak. How many ways can 10 people order? Like you're calling the restaurant for a takeout order. Okay, I need 5 fish, 3 chicken, and 2 steak dinners. Or can I have 8 fish, 1 chicken, and 1 steak dinner? Is this like a problem that we've done before?
0.
Yeah.
Oh, is this the
Or
one?
you could just have, I want no fish, no chicken, and just give me 10 steak dinners.
Is this the one?
This is
What?
balls in the boxes.
Oh.
That's like you have 10 identical balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many ways can you put them into 3 boxes? Because then that tells you how many of each that you order, right? So if you have 3 boxes, you need 2 dividers like that. So how many ways can you put these 2 dividers among those 10 balls? Wow.
12 factorial.
How many total things are there? This is like Mississippi now, 12 factorial. But then I got 10 O's, and then I got 2 I's, and then that's your answer. That's Mississippi. So this is the application of The balls in the boxes problem.
66.
Okay, well, I'll let you guys complete the answer. Plus got the answer on the bottom anyway, yeah? Number 11. Huh? Oh, logarithm again. Hey, we did this yesterday. Boo! I'm gonna give you guys a boo for that. I'm gonna give you a thumbs down. How many ways can you arrange these letters if the vowels must appear in alphabetical order? That sounds familiar. That's why you gotta build up a library, Lee. Your library is virtually empty. Because you're not doing the problems. That's right, Lee. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, where do you, just like yesterday, okay, there's only 3 vowels, like yesterday had 5 vowels, right? But now there's only 3. Where do you want to put the 3 vowels? Okay, so how many choices do I have for this one? No, they have to be in alphabetical order. So 1, that has to be the A, this has to be the I, and that has to be the O, because they have to be in alphabetical order. Now the consonants, they can be in any order, so how many choices do I have? 6, 5, 4, 3, 2, 1. This is exactly like this. But is that the only case? Vowels in positions 1, 2, 3? Yeah, so out of these 9 positions, how many ways can I pick 3 of them to be the vowels? Multiply by 9, choose 3. And then there's no repeated letters, so you don't have to do anything. Remember, yesterday's one had 2 S's, so you have to divide by 2 factorial. No.
Oh, yeah.
No. 12, 13, 14, that's the rest of it. Okay, 12. Now this problem seems difficult, but it's like really easy. Here we have a triangle, and there's 11 points on the circumference of the circle. 1, 2, 3, 4, 5, 6, 7. I forget. 1, 2, 3, 4, 5, 6, 7. We know these ohms. Is that right?
It's 11.
It says 11. Well, how many triangles can you make if these are the vertices? Yeah, out of these 11 points, how many ways can you select 3? Because every time you select 3 of them, it forms a triangle, right?
Oh, yeah.
So the answer is just 11, choose 3. Oh, that was easy. 13, oh, her cards. You guys never did like cards, huh? From a deck of 52 cards, how many 4-card hands contain 2 of one kind and 2 of another? So that's 2 pair, right? So do a specific case. A pair of jacks and a pair of aces. Too late. So do the specific case. How many jacks are in the deck?
4.
How many ways can I pick 2 of them? And then same thing with the aces, 4 choose 2. But here's the hard part. Now you gotta multiply it by the number of cases. Is jacks and aces the only way? What about aces and 10s? Or 2s and 5s? Or 7s and 9s?
13, choose 2.
There you go. See, you guys got it. B, is there a part B?
Yes.
3 of one kind and 1, so basically 3 of a kind then, right? So what, 3 what? 3 kings? And the 4th card is anything except the king, right? So how many kings are in the deck?
4.
So 4, choose 3. And then how many cards in the deck are not kings?
48.
48, and you need to select one of them, so 48, choose 1. So this is how many ways you can get 3 kings. But then what about like 3 jacks, or 3 queens, or 3 sevens? You multiply it by 13, right? And then the last one, number 14. Why, everybody got 15?
Oh, shoot, no.
No.
Of course not. Some of us didn't even look at 15. Anyway, might as well do it since it's on video. 5 times MP3 is, oh, come on! Okay, Baron's gonna have one of these problems on the test. Okay, what's the definition? So basically you gotta know the definition. What's the definition of MP3?
And choose 3.
No, this is choose. This is P. Yeah, but there's a formula for this. N factorial over N minus 3 factorial.
Oh, okay.
And what's the formula for this? N factorial all over 4 factorial, N minus 4 factorial. Now, let's simplify. Now, remember, after yesterday's thing, we should be good at working with factorials, right? So how does this simplify? Now, if you're still befuddled by factorials, write it out. Like, what does n factorial mean? N times n minus 1 times n minus 2 times n minus 3 times n minus 4, all the way until you hit 1, right? What is n minus 3 factorial? N minus 3 times n minus 4, all the way until you hit 1. Let the canceling begin! That's racist. So what's left? 5, n minus 1, n minus 2. Now on this side, how do we simplify?
124,
Do I need to write it out, or can we just see it? Starting from n minus 4, like if you were to write this one out, starting with n minus 4, they all cancel out with this, right? So all that's going to be left then is n times n minus 1 times n minus 2 times n minus 3 all over 4 times 3 times 2 times 1. And that's the shortcut for computing choose.
Wait, where did n factorial?
Wait, hold up.
Where did n factorial on the top?
Okay, let's write it out. What is n factorial? N times n minus 1 times n minus 2 times n minus 3 times n minus 4, all the way until you hit 1, right? 4 factorial is 4 times 3 times 2 times 1. What is n minus 4 factorial? N minus 4 times n minus 5, all the way until you hit 1. So starting from here, don't all of these things just cancel out like that? No, I know. Anyway, but isn't this the shortcut I taught you to compute choose, remember? You take this number, you write that factorial on the bottom, and since you have 4 things on the bottom, you just make sure you have 4 things on the top, right? Remember, because all the other stuff cancels out?
Is this gonna be like that?
Yeah, except this one's easy because look,
The 24.
24 cancels 24, and then, okay, can I do this? Oh, cancel n from both sides.
Yeah.
Yeah, well, you can, but because you're losing the solution, but what's the solution you're losing by doing that? N equals 0. Is it possible for 0 to be a solution? Is there such thing as 0 choose 4?
No.
No, when you use these notations, this number has to be greater than or equal to that number, otherwise it doesn't even make sense. There's no such thing as 0 choose 4 or 1 choose 4. Like if you have 3 candy bars, how many ways can I select 4 of them to go put in my lunchbox? That doesn't even make sense. So can I cancel n minus 1 then? Because 1 cannot be a solution.
Yes.
And then n minus 2, because 2 cannot be a solution. I'm waiting for the yes.
Yes.
So all we have left then is 5 equal n plus 3, so therefore n equal 8. Ka-ching! That's racist. Okay, the bell's gonna ring. Shall we just table 15 for next week then?
No.
The bell's gonna ring in
Can do.
30 seconds.
Can do.
No can do.
You can't do it.
No can do. This is period 8. Whatever that means. So somebody remember number 50. What, in fact, here, why don't you guys actually read it and try it now? Peterson is looking guilty over there.
What?
Now we have to upload this video.
Mr. Park, you're okay kicking out the word.
That's racist! Hey, don't be saying stuff like